Second, I think it got disconnected. Okay, sorry about that, it got disconnected because it gives sometimes problem, its connection is not stable. So it will be once again return in x greater than L and re-engagement at x is equal to L. And we already know that at x maximum our v was equal to 0 and omega was equal to our plus v naught upon 2r, and it is moving once again at x is equal to L minus, okay, just before reaching at x is equal to L. Therefore you can say at x is equal to L minus we are going to have our velocity v will be equal to minus v naught upon 2, okay, because basically which we have already calculated in the first case also, and our omega will be equal to plus v naught upon 2r. Okay. And once again our velocity of the contact point, that is our p, will be equal to our vp, and that is equal to v minus omega r, and that comes as a v is our minus omega upon 2, and this is equal to our plus v upon 2r times r, and this r and r goes away, and once again yes, my mistake, this is minus, otherwise it would have come 0, so this will be coming minus of v naught. And now we come to our part C. Okay, we have to remember this point P is nothing but our point of contact, and we come to a part C. And part C, it asks for what happens when the wheel next hits the gear track, and as soon as there will be re-engagement, gear is nothing but a friction, so as soon as there is friction there will be a re-engagement of the impulse. Therefore we can say that we have our re-engagement of impulse, that is our J. And once again same calculation we are going to do. I'm simply going to write the equations. We are going to get once again that our v prime will be equal to minus v naught upon 2 plus j upon m, and our omega prime will be equal to v naught upon 2r minus j upon mr. And for no slipping condition, because this will be re-engagement with the gear, which is nothing but our friction, so we can say we are going to have our no slipping, and for no slipping we know that our v prime is equal to omega prime times r, and we substitute our v prime as well as omega prime, and we get this as our v prime is our minus v naught upon 2 plus j upon m is equal to omega prime is our v naught upon 2r minus j upon mr times r, and here this r cancel out throughout, and we are left with v naught upon 2. This will be minus v naught, which will be equal to our j upon m. 1 second, I think there is some. So okay, and this comes as v naught upon 2 minus j upon m, and from here we get this as v naught will be plus v naught, so we get this as a v naught is equal to, and this will be our 2j upon m. So from here we can say our j is equal to m v naught upon 2, and therefore we can write that our v prime is our minus v naught upon 2 plus jm. So this comes as minus v naught upon 2 plus, this is 1 by 2 times, not 1 by 2 but j upon m, 1 upon m times m v naught upon 2, and here this m and m cancel out, so this will be minus v naught upon 2 and plus v naught upon 2, this will be equal to 0. And similarly we can say that our omega prime will be also coming equal to our 0. Therefore exactly at x is equal to L, so we can say at x is equal to L, once again our u will be equal to 0, because at x is equal to L the spring is in unstretched condition, so the total energy will be equal to 0. V prime potential energy will be equal to 0, v prime is equal to 0, and we have our omega prime is equal to 0, and our spring force is also equal to 0. So therefore the wheels come to rest and remains at rest. So we can say that wheel comes to rest and it remains at rest. It remains at rest. So this particular question, it looks a little bit tricky because of the language that was used in the question and the distance, because there is a continuous motion from, it starts with our no, and it starts from x greater than L, then it reaches x is equal to L, it comes to minimum position, then once again it comes to x equal to L, then goes x greater than L, and once again come back to re-engagement and engagement, that is rolling and slipping, that is the transition between these two. Okay, so that's the only tricky part, otherwise it is much more easier to solve. And we come to the last question, and it states that a uniform plank of length 2L leans against a vertical wall and rests on a horizontal frictionless floor. Initially, the plank is stationary. It begins to slip downward without friction. So, in this case, 1 second. So that the top end of the plank loses contact with the wall when it is descended to a height of 2 by 3 of its initial height. So we are given that we have a plank, suppose this is the wall and this is the base, and we are having a plank which is something like this, and the length is given as 2L. 2L is given as the length of the plank, and it is entirely frictionless, and it is given that it is initially stationary and it is going to slip downward, so it is slipping in downward direction, so this end is going to move like this. Okay, so we have to find out. It loses the contact when the distance is at the height is 2/3 of its initial height. Okay. So let us call this point as origin, and this coordinate we can call this as our x comma 0, and this coordinate we can call this as our 0 comma y. So therefore the total height is our y, and the initial distance, initial height is y, and initial distance, horizontal distance is our x. And from here, because in this questions the solution will be based on one important equation that we can call it as a length constraint. Call this a length constraint. And that length constraint is the relationship between the base height as well as the, you can say, the ladder length, whichever x square plus y square is equal to 2l whole square, which will be nothing but 4l square. Therefore from here we can write that our value of x will be equal to 4l square minus y square and its square root. And the center of mass of the plank, center of mass of our plank will be equal to x by 2 and y by 2, its coordinate. And if it is making an angle of theta with the floor, so we can say that our sine of theta will be equal to y upon 2l, and our cos of theta will be equal to x upon 2l. And we are once again going to come back to this equation, and you can say differentiate it and get the various values, kinematics relation to it basically. So we can say that our x square plus y square is equal to 4l square. So we differentiate it, we get this as our 2x x single dot plus 2y y single dot is equal to 0. And single dot basically means our velocity. So we can say that our y single dot will be equal to minus x upon y times x single dot. And we are going to differentiate again. We are going to get the acceleration, that will equal to minus, and we have our y, and this will be our x double dot times y minus single dot and y single dot. And we already know our y single dot, we substituted here, we get this as minus this is your y, and we are having x double dot and y minus x single dot, and this comes as minus x upon y, and we are having this as our x single dot. Therefore we get our acceleration, that is our y double dot will be equal to, this will be equal to minus x double dot y, and we get this as our minus minus will be plus, and this will be x single dot whole square, and this will be divided by y and divided by y. Okay. So we can just write it for the simplification, x double dot plus x single dot whole square divided by y square. Okay. So now we can easily find out our angular velocity, because angular velocity will be equal to our derivative of our theta. And for that we can say that suppose the plank rotates about its center of mass with angular velocity which is omega, and that will be equal to theta single dot. And we already know, we have written trigonometric formula, that is our sine of theta is equal to y upon 2l. So we are going to take its differentiation and we get this as our cos of theta single dot will be equal to 1 upon 2l and y single dot. From here we get our theta dot is equal to this comes as 1 upon 2l cos of theta times y single dot, and cos of theta we already know is our x upon 2l. So this comes as 1 upon 2l and this is x upon 2l times y single dot. This 2l cancels out, and from here we get that our theta dot is equal to y dot upon x. But we know that our y single dot is our this relationship. So we substitute it here, we get this as 1 upon x times this again is minus x upon y, and we have our x single dot, and here x and x cancels out, and this will equal to minus x single dot upon y, and theta dot we just said that it is our angular omega, so this comes as our omega. And if we square them, we get that our omega square is equal to x single dot square divided by y square. And anything else we are okay, we have to find our height, and let's find out the kinetic energy of, because the kinetic energy of center of mass will be translational and as well as the rotational. So we start with our total kinetic energy, and total kinetic energy of center of mass. So we can say our kinetic energy translational of center of mass, and for that we will be requiring the velocity of the center of mass, okay, because translational will be equal to over half m v square and velocity of the center of mass, and velocity of center of mass is our, okay, let me substitute it here itself. So this comes as half m, and our velocity will be equal to double derivative x dot 2 whole square plus y dot 2 and whole square, okay. And so we get this will be equal to over half m. We have our this, we can take our 4 will be our outside, so we can write this as our 8, and inside we are left with our x dot square plus y dot square, and y dot we already know, so this comes as 1 by 8 times m. This is our x dot plus y dot is our x upon y, x dot. Negative will be positive, so this will be coming as x upon y, x dot, and its whole square, and this is a square. So from here we get this as 1 by 8 times m. This will be our x dot square plus x square y square, and we have this as x dot square, and x dot square we can take as common, so this will be coming as 1 by 8 m x dot square, and we can take this as LCM. So we have our y square and x square plus y square, and x square plus y square is our 4l square. So we get this will be equal to 1 by 8, and we have this is m x dot square times this is our 4l square upon y square, and this 4 goes by 2, so miss something. This is our half 4 8. No, it's correct. So this comes as our 1 by 2, and we have this as our m and l square x dot square upon y square. This is our translated kinetic energy with respect to center of mass. Now we find out our rotational kinetic energy. So we can say our kinetic energy rotational with respect to center of mass, that will be equal to our half moment of inertia of the center of mass and omega square, and moment of inertia of our center of mass, that is the center of the rod. And here we have to remember that the rod length is 2l. So we can write this as our 1 upon 12. This comes as m, and this is about 2l whole square and times omega square. And we can substitute value of omega also. Omega is our x dot upon y square. So this comes as our x dot square upon y square. So this comes as our multiply by 1 by 2. So we get our kinetic energy rotational for our center of mass. This will be coming as 4 3, then will be 1 by 6, and we are having this as our ml square, and this will be our x dot square upon y square. So we are supposed to find out our total kinetic energy, and let us suppose that is our T, and this is for center of mass. So we can say our T center of mass will be equal to kinetic energy translational for our center of mass plus kinetic energy rotational for our center of mass. So we simply substitute the values. We get this as our 1 by 2 ml square, and we have this as x dot and y square plus 1 by 6 ml square x dot and y square. Okay, so everything is same. So this is 1 by 2 plus 1 by 6. LCM will be 6, and that will be 3 plus 1, that is 4. 4 by 6 giving us 2 by 3 ml square x dot and y. Now we come to a potential energy, because we found out the total energy of a center of mass, but there will be also the potential energy associated with it. So we can say that total potential energy, and let us call that as our V. And so initial height is our, because everything is with respect to the center of mass, so we are going to find out the potential energy, total potential energy of center of mass, and we are going to call this as V center of mass. And we know that initial height of center of mass, let us call this as our h naught, and that is equal to nothing but our y naught upon 2. And one second. This is initial, okay, and the current height of center of mass, current height of center of mass, let us call this as h, is equal to y by 2. Therefore, we can say that our therefore we can say that from here, let me write this as our, one second, potential energy of our center of mass, height is this, and initial height, current height. Okay, so we get that our velocity, energy of a center of mass is equal to our mg h, and that is our y by 2. Therefore, total energy can say that our total energy, which is our E, will be equal to so total initial energy, total initial energy, because initially it was at rest, so only energy will be potential energy. Let us call this as our E, and that is at a height of h naught, so this comes as our mg y naught upon 2. Now we can use our conservation of energy. So we can say that our, because we found out that the total energy of the center of mass, which is combination of kinetic as well as rotational, and the total energy of the potential energy with respect to center of mass, therefore we can say that the energy conservation of energy. This means that our TCM plus VCM is equal to our E. Now we simply substitute them. We get this as our TCM was our 2 by 3 ml square, 2 by 3 ml square x dot and y square plus VCM is our mg y upon 2 and E is our mg y naught upon 2. Now it is simple a matter of calculation. So we can take this on the left side, right side rather. So this will be coming as 2 by 3 and we can cancel out m throughout. So this will be L square x dot and y square is equal to G we can take as common and we get this as y naught upon 2 minus y upon 2, which is nothing but G upon 2 y naught minus y. And from here we can say that our y dot square is equal to, we come this as 3 by 2 times G upon L square and not 3 by 2 but it will be 3 by 4. So this comes as 3 by 4 and we have G upon L square and y square y naught minus y. Now we come to our forces and our equation of the motion. So we have our forces and equations of motion. And forces will be, first will be our gravity mg, and okay, let me draw it here. So we are going to have our mg and we are going to have two normals. One will be from the wall n and other one will be from the base floor, that is our nf. So this will be three forces. So we can say our forces, first one is our mg and it will be downward and this is our center of mass, and then we are going to have a normal from the wall which is our n and that is toward right, and we are going to normal because of the floor that is our nf and it will be in upward direction. So therefore there will be two types of motion. We can say our horizontal motion as well as our vertical motion of the center of mass. So we can say that our horizontal motion of center of mass, and we can write this as our m, its acceleration is equal to our n. Okay. and because in horizontal direction there is only one force, that is our N. And then we can write our vertical motion of center of mass. Vertical motion of center of mass, that is our M y double derivative center of mass, and we are going to have two forces. One is our NF minus mg, and okay, we already know that our this xm is our x by 2, so I can write this as our m times x double derivative of x divided by 2 is equal to n. So from here I get n is equal to m by 2 and x double derivative. And from the second part we can write this as our m y double derivative divided by 2 is equal to nf minus mg. And we already know that our x single derivative we already know, so we differentiate it and get double derivative, okay, because we are required here. So we know that our x single derivative is equal to, this is 3 by 4 g upon L square. This is y naught minus y and y square. Sorry, one second. I have written it wrong. Oh yes, I have written it wrong. It should have been product, not in. So this will be equal to our y naught minus y, and this is our y square. Okay. Y naught, I think, yeah, now it's correct. So this comes as a y naught minus y multiplied by y square, and we differentiate it, and so we differentiate it and we get this as our 2x and double derivative. This will be our constant, and we get this as our y naught minus y. We can use the product rule, and this will go 2y y dot, and this will be minus, and this will be coming as our y square times y single dot, and you can just open the bracket and try to solve it. So this comes as our 3g 4l square, and this will be our 2 y dot we can take as common, so this will be our y dot, this and this, so this comes as our 2y y naught minus 2y square minus y square. Okay, so this gives us 3 by 4 g y dot L square, and this will be giving us 3y square, and we get this as 2y y naught minus 3y square, and this is equal to 2x single dot and double dot. And we already know that our y dot is equal to minus x upon y x single dot. So we substitute it. So we get this will be equal to 3 by 4 g upon L square, and this is our minus x upon y and single dot. This comes as our y, we can take as common because okay, we can cancel it out. So this comes as 2y naught minus 3y times y, and this equal to 2x dot x double dot. So here this x dot cancels out, this y goes with y, and rest we can just keep it as it is. So we get this as our twice x double dot is equal to 3 by 4 g upon L square, and this will be our minus, and we have our x, and this is equal to twice y naught minus 3 times v and 3 times y, and we simply divide by 2 now. So minus 3 by 8, we have this is g of x L square twice y naught minus thrice of y. And now we can find out the normal forces, that is our N is equal to m by 2 and x double dot, which comes as our m by 2, this is minus 3 by 8, and we have gx L square twice y naught 3 times y, and okay, negative we can just for the time be ignored because we can find out only magnitude. So we can say our magnitude will be equal to, this will be equal to 3 by 16 gmx L square, and we have twice v naught minus thrice, and this will be positive for if our twice y naught is greater than thrice v, and it is going to lose contact with the wall when this value of n is equal to 0. Okay, we are almost done now. So we can say that our loss of contact will be equal to when value of n is equal to 0. This is universally true for any problem. Whenever we talk about loss of the contact, the value of the normal force will automatically be equal to 0. So we can make this entire term is equal to 0. So obviously this is our constant, it cannot be equal to 0. Therefore we can directly say that our 2y naught minus 3y is equal to 0. So from here we get our y is equal to 2 by 3 times y naught. So it is 2 by 3 of our initial value, which was asked for 2 by 3 of our initial height, okay, which we have assumed 2/3 of our initial height. So finally all the questions, 4 questions are complete. Okay. In this session, in this 4 questions, only one of them was the tricky part, that was with respect to our that the motion is shifting from our rolling to slipping to rolling, and that is going to and fro. That was the only tricky part, and in that case we have to remember that it is indirectly talking about the friction. Okay, that the teeth is the representative of the friction. When there is engagement, there will be presence of friction. When there is disengagement, the friction will be gone. Okay, so this completes all the 4 questions. Thank you.